Okay, let's go ahead. I'm going to share my screen.
And mine hasn't finished printing yet.
Yours is still working. It's fine. Got a minute.
It's almost done.
All right. Let's get this thing where it needs to be so I can actually write. I need 2 desks to do this on. Okay. Here we go. Ready? I think we're ready. Last, 5 minutes in here, but okay, let's go. So, question.
Miss Kessler, sorry. Could you record, please? Could you record the class?
Yes, it is getting recorded. Okay, how can we tell how many solutions a polynomial equation has? Anybody with a thought on that? Becca? Okay, so Becca says we can look at the intercept. She said y-intercept, but I think she means x-intercept. And she said we can also look at the degree of the polynomial. If it's 3, we can look for 3. If it's 4, we can look for 4. Okay? And in fact, that's exactly true. If we take a look and we open it up to the complex numbers for our solutions, a polynomial equation is going to have the same number of solutions as its degree. So the same number of solutions as its degree. And that's going to be in the set of complex numbers. So if we just look at a graph, it's going to tell us how many real solutions we have. Like Becca said, if we look at our x-intercepts, that'll tell us how many real solutions we have. But if we open the solutions up to the set of complex numbers, it's going to be equal to the number of the degree of the polynomial. And that is kind of what this fundamental theorem of algebra says. I don't know why they call it the fundamental theorem of algebra. I guess because algebra is always looking at solutions to equations. And so it tells us how many solutions we're going to have. So it says if f of x is a polynomial equation of degree n, where n is greater than 0, then the equation f of x equals 0 has at least one solution in the set of complex numbers. Okay, that one says it only has at least one. If we go to the corollary, it tells us more specific information. If f of x is a polynomial equation of degree n, where n is greater than 0, then the equation f of x equals 0 has exactly n solutions in the set of complex numbers. If we count each multiple solution as a different solution. Remember, sometimes we got like x equals 2 a solution twice. So if we count all of those, we're going to get that many solutions. Okay, let's go through and just do some problems with solving. Because we're going to use the techniques that we've learned in our previous lessons to find all the solutions of a polynomial equation. What are some of the techniques that we have learned for solving polynomial equations? Hannah. Hannah says factoring. Emma?
Synthetic division.
Synthetic division, which in a way, it's one of the techniques that helps us factor. So those go together. That's one of our techniques of factoring, which I love. Becca touched on one already. We could look at our graph and find the x-intercepts. Okay, what else can we do? That's pretty much it, right? What helps us in synthetic division? Remember, we have the idea of a p divided by q. What was that p divided by q that we talked about last week?
The constant term divided by the wait, what's it called?
Mikhail, say it again.
It's the constant term divided by the what's it called? It's the something of the first term. It's the leading coefficient.
So factors of the constant term divided by factors of the leading coefficient. That helps us figure out what to use in our synthetic division. It helps us take a look at our graph to know where things are. So those are things to just help us with that. Okay. So here we go. we want to first off state how many solutions we're going to have in this set of complex numbers and then find them. So the first question, okay, Emma.
We have 3 solutions.
Okay, we have 3 solutions. And what's something that I can do to start solving for that? Oh, let me pick on somebody else. Daniel. You're kind of thinking about maybe an idea of completing the square maybe, but actually this is in standard form and we have 4 terms. We did some factoring technique.
Factor by grouping?
Yeah, exactly.
Yeah, group.
Yeah, Daniel says we want to separate these 2. Okay, so we're going to do grouping, factor by grouping. Okay, so out of our first pair, we have a common factor of x squared. So we're going to factor that out, leaving us with x plus 3 in parentheses. And our second pair has a common factor of 16, leaving us with x plus 3. And we divide that out. Okay. So when we complete our factoring, we have the common factor of x plus 3. And when we factor that out of each one of these 2 terms, we're left with x squared plus 16. Okay.
And it can't be factoring more because it's addition, right?
Yeah, we can't factor this more because it's an addition of 2 squares instead of a subtraction or difference. But let's set each one of these factors equal to 0 and see what we get not only in our real solutions, but in our complex solutions as well. So x plus 3 equals 0 gives us,
-3.
okay, -3. Emma says -3. And what happens with the x squared plus 16?
It's 4.
Okay, you
It'd be
guys
4, right?
we're going to subtract and get -16.
Oh, it'd be 4i.
Yeah, Eli's got it. Let's go through and get it. So we want to undo the square by doing our square root. So we have plus or minus the square root of -16. And that means the square root of 16 is 4, and the square root of -1 is I. So we have x is plus or minus 4i. How many solutions do I have? Do I have 3 solutions?
Yeah.
Yes.
I have,
-3.
You have -3
4i and
plus or
-4.
minus 4i, yeah.
okay, so 1 real, 2 imaginary, for a total of 3 solutions in the complex set of numbers. Okay. All right, let's do another one.
Yeah, well, that's what's-
This one's phrased a little differently. Notice this
Can
one
you
has
take out x?
solution equal to 0.
Hang on. I have a quick question. In a cubic function, don't we know that it automatically has to have 1 real solution just because the way that it's shaped?
Yes, all cubic solutions. Remember what a basic cubic graph looks like? Here's our parent function. It always has to cross the real x-axis at least once. So we are always on every cubic equation, we're going to get at least 1 real solution.
So that's a difference between cubic functions and some quartic functions and quadratic functions.
Yes. Okay. All right. So let's look at our question here. In example 1, our equation was already equal to 0. In example 2, we don't have it equal to 0. It says f of x equals, but our instructions say to find the zeros. So that means I want 0 equal to. I want the f of x to equal 0. Okay. We have 4 terms, but we've got a little bit of a different thing to do to start this one. What should I do?
Take out x?
I'm gonna go with somebody in the real life here. Hannah, what can I do to start? I don't even need to do that yet. What can I do with our techniques? Factor out an x. Okay. So I can factor out an x. And when I do that, that leaves me with x cubed plus 6x squared plus 12x plus 8. Okay. Now this problem looks exactly like the one that we did before. So can we factor the part inside the parentheses by grouping?
Yes.
No,
Yes.
wait, we can?
Emma says yes, and so does Eli. So here we go. Our first pair is x cubed plus 6x squared. And our second pair, 12x plus 8. Okay.
Wait, I don't think this can be grouped, can it?
Factor?
Yeah, it can. We just leave X on the outside. Why can't it?
Oh, does that work? Ah, that
No,
doesn't work.
It doesn't
Oh,
work,
Oh,
yeah.
it doesn't.
okay.
Yeah.
You
Darn,
can't take out 12 because 8 is, yeah.
what can we do then? We can do a P over Q. So our leading coefficient is 1 and our constant term is 8. So P
It'd be
has
1, 2, 4, 8.
factors of 8. Q has to be factors of 1. You guys are ahead of me. I'm going to write it down in case anybody's not sure what's going on. So factors of 8, as you said, 1, 2, 4, and 8. And factors of 1 are just 1. And of course, we always have plus or minus.
Can we narrow it down before we do synthetic division?
Okay, so let's go ahead and put our candidates for P over Q. Since Q is 1, life is easy. It's plus or minus 1, 2, 4, and 8.
Yeah, it's great when that happens.
Okay,
Remember there was one problem on the homework when there were so many.
how can I narrow this down? Josh, how can I narrow this down? I could plug it in, but I can narrow it down before. Okay, so, but I got 8 choices. How can I narrow down my 8 choices? Graph it. Graph it.
It's nice that
Oh.
we're allowed to do that.
Yep. So let's go back. I don't have my Desmos open up yet. Let's see.
Wait, can you share a screen to Desmos? Alright.
What's that? Somebody got Desmos open already?
Never mind. No, I was gonna ask you to share a screen if you open Desmos.
Okay. Yeah. I can't get to. Okay, so Desmos, I'm going to graph just the part. Oh, I need to share the screen. Share screen. You guys can see. Here we go. All right, everybody seeing the screen? I am just going to graph the part that's in parentheses after I factored out the x. So I went y equals x cubed plus 6x squared plus 12x plus 8. Well, looks like I've got one possibility, -2. It's the only one that looks like it works.
Hooray.
So let's take the part that's in parentheses. Let me just go back to my new share. Okay. And let's do synthetic division for -2 on the part that we looked at in our graph. So we have 1x cubed, 6x squared, 12x, and 8. Okay, I don't know if Nora has ever seen synthetic division. So this is new for Nora. What we're dividing by is x plus 2, and here's what we end up doing.
Got it?
Bring down the 1, and then -2 times 1 is -2. We now add those, so 6 and -2 is 4. Then we multiply, -2 times 4 is -8. Add to get 4, multiply, -2 times 4, -8. And this part right here is our remainder. It's our function value. Since the remainder comes out 0, it's crossing the x-axis because our y value is 0 there. And it leaves us with this new polynomial 1 degree less than what we started with. We started with 3, so we're down to 2. So we have x squared plus 4x plus 4. let's write all those factors that we've gotten so far. Okay, these are all the factors that I've gotten so far. We had x, we had x plus 2, and then we have our new one here, x squared plus 4x plus 4. Say that again, Josh. This one, okay,
Can we do x plus 2?
yeah. So this factors to x plus 2 squared. Gosh, what do you notice about my x plus 2 as a factor? X plus 2 is a factor 3 times.
That's pretty
X
crazy.
plus 2, x plus 2, and x plus 2 again. Yeah, it's a multiplicity, so we can write it this way. So here's my zeros. X is 0, and x plus 2 equals 0 3 times. So x equals -2 is a 0 of multiplicity 3. Okay, it's an odd multiplicity, so it's going to cross the x-axis because it's odd multiplicity. Is that what we saw in our graph? Yeah. Okay, so do I have 4 zeros?
Yeah.
Yeah.
Yes. Oh wait, hang on. What's the significance again of multiplicity 3? Like just what would that look like on a graph? What would that change about it? I don't remember.
Okay, let's go back.
Also, how did we get x equals 0 again?
Oh,
Then you
because we had an
factor-
x on the outside from that we factored from the
and then
very
you- yeah,
beginning.
exactly.
The first thing we did was factor out an x from the very beginning of the problem, and then so since that x was just left open on the outside, we
You're right.
Okay, so what I've got here on the graph is the whole function with the x factored out. That's our x equals 0, it crosses here. Is this a 4th degree polynomial?
yeah.
How can I
Yeah.
tell?
Because if you
Because
were
it's
to distribute the if you were to distribute the x, then it would be x 4.
4th, yes. Yeah, x times x cubed is x to the 4th. Oh, for a moment we lost power here. It's back on, but I don't know. We just lost. Don't worry about it right now. Let's work on math. Math, guys. The lights are on, electricity's working. Math, here we go. You can't see the screen. Never mind. Let's see if we can reconnect. Okay. Our